Our next video is going to focus on the topic of dilution. And typically, a solution is purchased in high concentrations, and water is added to dilute this solution to a desired concentration. So we can look at how these solutions are kind of made, and we can, economically, it's a lot of times very easy to purchase something with a high concentration and dilute it to a lower concentration. So no matter how much water you add to a solution, one thing does not change, and that is the moles of solute. So if we look at our concentration, which is equal to moles of solute divided by liters of solution, if we're looking at a dilution and we dilute with water, the moles of solute will remain the same, and the liters of solution, by adding water, we are going to increase the volume. So therefore, the molarity or concentration decreases when water is added. And this is referred to as a dilution. So let's look at an example problem using the concepts that we just discussed here. So the example that we're going to say is going to be the following. If you have 10.0 milliliters of water and 1 drop of concentrated H2SO4 is added, what is the concentration of H2SO4 in the resulting solution? So this is going to bring up a few points here, and the first one is going to deal with this concentrated acid. And concentrated acids are going to be very, very, very potent, and they're going to have very, very high concentrations. If we have concentrated HCl, it's in a concentration of 12.0 molar. Concentrated H2SO4 has a concentration of 18.0 molar, and concentrated HNO3 has a concentration of 15.0 molar. So most of the acids that you use when you perform each of your laboratory experiments are made from purchasing these very, very concentrated solutions, and then they're going to be prepared by dilution of these concentrated acids. And you're going to find that as we progress later through some of the chapters in our book, that by varying the concentration of these acids, we're going to see a vast difference in their reactivity and the properties of their resulting solutions. Another thing that we need to recognize is the term drop. So when we use the instruments in the lab, if you use a medicine dropper, roughly 1 milliliter is going to be equivalent to about 20 drops. So 1 drop is roughly 0.05 milliliters. So in this case, we're taking 0.05 milliliters of H2SO4, and first, in order to find the concentration, we need to convert this over to moles. So we know that there are 1,000 milliliters in 1 liter, and the concentration of our H2SO4 is 18.0 moles of H2SO4 per liter. So the milliliters cancel out, the liters cancel out, and this gives us 0.0009 moles of H2SO4. Remember that the number of moles right here stays the same regardless of the solution volume. So in the solution that we have, no matter where we put that 1 drop into 10 milliliters to 20 milliliters or 100 milliliters, the number of moles of H2SO4 is going to stay the same. So if we have 0.0009 moles of H2SO4 divided by, and we can say this is our concentration, 0.0105 liters, which this volume right here is going to be the 10.0 milliliters plus 1 drop. This is going to give us a value of 0.0857 molar, which we only have one significant figure here, but we're going to get 0.09 molar for our concentration of H2SO4 in this solution. And even though this value looks really, really small, if we do the math, it's going to give us a pH that's going to be less than 1. And we're going to talk about pH in a later chapter, but this is still a pretty acidic solution. So this uses the concepts of dilution and concentration in solution to look at how we would calculate various concentrations.